So for recitation, let's just assume that you have already showed them the Play game-like app. You've walked through, you've run the code, and now basically what you're going to be doing is scaffolding the problem by explaining specifically, not the entire game, but how do we get it so that we have a grid on the screen, and when we press up, right, left, right, down, when we click, we actually move the grid when the player stays in the center. So make sure also to mention, we're gonna assume that the students have a lot of knowledge about how grids work. So make sure that you talk about that if they have questions about that. Okay, so this is how it's going to be done. So for Play game-like app, what we're doing is we actually have a board which is larger than the size of the screen. So if you imagine that this is the screen that's viewable, and let's say that this screen is 300 by 300, what we're actually going to do is have a board which, let's say that let's define some variables here. So we have our height equals 300, so data.height, our data.width equals 300. But now we're also going to have a board width. Board width equals, let's say that it's 600. So the board that we're making actually is twice as big as the screen. It's equal to 600, and it's a square board, so the board height is equal to 600. So for this board, let's say that we want to have 10 rows and 10 calls. So data.rows equals data.calls equals 10. So the first question that we should ask is, what is the cell size of each board going to be? Now, if the board was just going to fit on 300 by 300, then the cell size would simply be the height of the screen divided by the number of calls. However, since we have a larger board size, we're going to say that the cell size is the board width and the board height divided by the number of rows and calls. So we're going to have data.cell size equals the board width, so board width divided by rows. Since it's all symmetric, we can just do, every cell is going to have the same width and height, and it's going to be 600 divided by 10, so 60. Now, we're going to draw this board the same way that we've drawn every single board in the past. Our goal, the first goal that we're going to have is simply to just draw the board on the screen, but it's going to be too big. So the way that we can do that is the same way that we draw the grid in Draw Grid Demo, where essentially we loop through the rows and calls, and we determine for each specific row call what the dimensions of that are on the screen. So to just go over that really quickly, we basically have for row in rows, for call in calls. And now we're looking at a specific, let's say that it's 0, 0. We're looking at the 0, 0 cell on the board. We now have to map that onto the screen by finding the bounding box, or the x, y coordinates of the top left and the top right. So right now we're trying to find this cell. So we find this point and this point. And we can do that really easy by saying x0 is equal to the cell that we're looking at. X is in the column direction, remember? So it's going to be the column times the cell width, or the cell size. Y0 is going to be the row times the cell size. And then x0, x1. So this is x0, y0 is defining this point. x1, y1 is going to be defining the point on the other end of the rectangle. But notice how to go from here to here, it's just one cell size, and to go from here to here, it's another cell size. So we can do x1 is equal to x0 plus cell size, and x2 is equal to y0 plus cell size. Or y2, sorry. y1. Okay, and then after that, we just go through the motions of creating a rectangle, and that's going to make a nice little rectangle in every single cell, and it's going to look great. So because we have a width and height, which is actually 600, which is bigger than the board, or the board is bigger than the screen, our actual board is going to be drawn off the screen. Now, an important thing to note for these side scroller type things is that when we draw things off the screen, that's completely okay in Tkinter. It's basically as if it's been drawn, but we can't see it, so that's not a problem. Now, the whole crux of this Play game-like app is that we need to be able to actually pretend that the player is located right here on the board. Let's say like this. So there's a player located at the center of the board, and the board moves around. So like, let's say the player presses up. Now when the player presses up, which would be handled in key press, essentially we need to not shift the location of the player. The player is always going to be at the center of the screen. What we do need to do is shift the entire board so that it appears like the player moved up. Now let's think about what it needs to look like for it to look like the player moved up. So in order for the player to move up, the player should be higher up in the board. Now in order to accomplish that, we actually need to move the entire board down. So like a quick example, let's say that this is originally, like let's say this is where the player is. Then if the player moves up, then like, let's do it like this. So this is like the screen and this is like the grid. Now when the player moves up, the player still stays in the center, but the entire grid shifts down. And so in order to keep track of how much the player has moved up or moved to the left, what we need to do is actually keep track of what we're going to call an offset, which is basically how much down or up, left or right, to draw the grid. So let's keep track of an offset in the x direction and the y direction. And essentially that's going to tell us whenever the player moves up, we need to put some offset so that the board moves down. Whenever the player moves to the right, we need to put an offset so that the board moves to the left, so on and so forth. So we're going to keep track of data.offset x, started off at 0, and data.offset y, started off at 0. So now, let's think about the different scenarios. Well, if the player presses up, so let's say we're in my key pressed, and event.data is equal to up. Now, if the player presses up, that means that we need to shift the board down. Now, in order to know what that means, let's think about how we're actually going to draw the board based off of the offsets. So I need to basically move the board down, which means that the offset should increase positively. Because I'm going to add, let's say like 5 to the entire board so that it moves down. So now I'm going to say data.offset y plus equals 5. So that's going to increase my offset when the player presses up. But then when I actually draw the grid, so here I have like draw a grid, what I actually need to do is instead of just calculating the x0, y0, x1, and y1, I need to actually add in the offsets so that it shifts the entire graph down. So now instead of, let's go back to this screen where it's just a single box. So instead of this box just being here, I actually have an offset. And that offset's going to move it down a little bit and to the right a little bit and draw the box here. So in order to do that, it's basically going to be what the original x0 was, except just add in my offset. And then similarly, the y0 is going to be the same thing, but add in the offset in the y direction. So now, when I press up, I'm going to increase my offset by 5. But what that's going to do is draw every cell 5 lower, which means that originally, if I was over here, then I press the up arrow key, this box is going to move down by the offset, which makes it look like the center moved up. Similarly, we can think about all the different directions. So let's say if the event is equal to left. So if the event is going in the left, that means that I need the box, like if the player is going to the left, I need the box to move to the right. So for instance, I need to go from here to here, so that it looks like I moved to the left. So in order to move everything to the right, I need to add to my offset x. So data.offset x plus equals, let's say 5. And then alternatively, if I'm going in the right direction, then I need everything to shift over back to the left. So I'm going to add or subtract 5 from my offset, minus equals 5. And so on and so forth. So we can basically map out all the different directions, like down would just be the opposite of up. And we would be able to then show that the screen is shifting But the key point is that the circle or the center where the player is never changes. But when we actually change, like when the player goes up, down, left, right, we're actually just offsetting how we're drawing the board so that it appears as though the player has moved. Cool. So now the last thing that's going to be really tricky for Play Game app, or Play Game like app, is basically how do we actually figure out what row and call in the board you are looking at based on where you are, where the center is. And so it turns out that we can think about this problem the way that we do the grid-like demo, or the grid demo. Like let's say that we just had a normal grid. And I want to basically figure out where this dot, what row call this grid is on, or this dot is on the grid. So what I can do, what we normally would do is say def, let's call it like get cell. And it's going to pass in the XY coordinates of where the board is, or where the circle is on the grid, or on the screen. So for instance, it would be like X and Y. And remember, X and Y are like TK inter coordinates for where the circle is. So for our purposes, the circle is always in the center, so it would be width divided by 2, height divided by 2. Now, what we need to do, like if there was no offsetting or anything, we would basically need to say, okay, how many cell widths have happened in the X direction, and how many cell widths have happened in the Y direction? So for example, in here, in this situation, we're in the second row and the second column, and let's say that my cell width is CW. So far I've had 2 CWs, and then a little bit more. So basically what I need to do is find the number of CWs that go into this X, and find the number of CWs that go into the Y, and that's going to give me 2 and some change, so interior division we get 2, and then the Y direction, it'll give me 2 and some change. So then we can basically say that the row is equal to X divided by cell width, and the call is equal to Y divided by cell width. Now the only difference and this is all in the grid demo. Now the only difference that gets encountered now that we have an offset is that we essentially need to negate the offset and make it so that we lock back to the original grid without the offset. So we're drawing the offset with by adding it. So in order to negate the offset, we just subtract it. So instead of doing X divided by cell width, I'm just going to simply do X minus offset X, and then divide that by cell width. And similarly in Y direction, Y minus offset Y divided by cell width. So now what this is going to do is first lock the grid to the top, and then do the old way that we've done to basically figure out the row and the column. And so this is going to tell me what row and call in the grid the center of the screen is looking at. So every time we call get cell, since the X and Y is always the center of the screen, we'd always call like get cell with width divided by 2 and height divided by 2. But note, these are the width and height defined over here, which is of the screen and not of the board. Yeah, so that's basically it.
Nice.